Welcome to the lecture series Programming in C. In this module, we will be looking into bitwise and special operators. Out of the list of operators, we have already seen few operators, and now in this module we will focus on bitwise operators and the special operators in C. What are bitwise operators? The bitwise operators are used for operating or manipulating the data at the bit level. So, for which we need to know the binary representation of a decimal value. Say for instance, if we consider the 4-bit representation of the decimal values in terms of binary, we can make the representation starting from 000 will be for decimal 0. And 0001 will be used as a representation for decimal value 1, and 0010 will be for 2, 0011 will be for 3, 0100 will be the decimal value 4, 0101 will be for 5, and 0110 will be for 6, and 0111 will be for 7, and 1000 will be for 8, 1001 will be for 9, 1010 this is for 10. So, it goes on up to 16. If we are using the binary representation with 4 digits, 4-bit values, then 2 power 4 16 number representation, decimal numbers can be represented starting from 0 to 15, can be represented using the binary bits. So, here with respect to the binary value, if we want to do some operations, and the bitwise operator will help us operate at the binary level, bit level. Okay. So, henceforth we call it as bitwise operators. So, bitwise AND, which is actually represented with the ampersand symbol, which is used to perform the AND operation bitwise. It means that if both the inputs or both the binary values are going to be 1, then only the result will be 1. In case of bitwise OR operation, if either one of the bit is 1, the output will be 1, or otherwise it is 0. The bitwise OR operation, XOR operation, will result in only when both the inputs are going to be 1 or both the inputs are going to be 0, then the result will be 1, otherwise it is 0. Then 1's complement will be able to change the value bit from 1 to 0 and from 0 to 1. And we have shift operators, left shift and right shift operators. This is used to shift one bit towards left if it is left shift, and towards right if it is right shift. And this can be applied for n number of times in case if n number of bits to be shifted left or to be shifted right. By doing the left shift operation, the process of multiplication is carried out. By doing right operation, the process of division is carried out with respect to its value representation. So, we will focus on bitwise AND operation. As we have already seen, the bitwise AND operator compares each bit of its first operand to the corresponding bit of the second operand. If both bits are 1s, the corresponding bit of the result is set to 1, otherwise it is 0. Since C handles the bitwise AND operator with both associative and commutative property, we can rearrange the operands in any of the order in an expression. The bitwise AND operator should not be confused with the logical AND operator, We use double ampersand symbol for logical AND, which is actually used for operating expressions, but here single bit single ampersand is for bitwise AND operation, which is used for evaluating the bitwise level. Say for instance, the value 1 and value 4 is evaluated. It means that value 1 is represented using binary representation of 4 bits as 0 0 1 for 1 and 0 1 0 0 for 4. So, if we apply the AND operation, which is going to compare the first bit with the corresponding first bit of the second operand, if both the bits are going to be 1, the result is going to be 1. But since none of the bits AND operation is 1, we get all zeros when we evaluate the AND operation between 1 and 4. The same way, the logical operator, if it is applied for 1 and 4, between 1 and 4, it results with the Boolean operation of true ampersand, double ampersand, that is logical operation and true, that results in the value true, which is not the same as we get with the bitwise operation. Considering a 16-bit binary pattern, we will assume num1 and num2 with two different patterns, and by applying the AND operation, we get if both the inputs are 0, the output is 0. If one of the input is 1, again the output is 0. If again one of the input is 1, the output will be 0. Only when both the inputs are 1s, we get the output bit to be 1. On applying this rule, this truth table for the given example, we can now evaluate that. We will start from the right hand side. 0 1 results in 0, 0 1 and results in 0, 1 and 0 results in 0, 0 and 0 results in 0, 0 and 1 results in 0, 1 and 1 results in 1, 1 and 1 results in 1. So, we can see that this part of the input has both the values to be all ones, only then the resultant value will be the bitwise 1. So, this is the way the bitwise AND operation is evaluated based on the truth table. If it is applied in a program, how to use the bitwise AND operator in a program? Very simply, we can use the integer values as decimal values 12 and 25 for example, and we perform the AND operation bitwise. If we give the bitwise AND operation, automatically the value integer values will be converted to its binary equivalent. So, the binary equivalent of 12 and the binary equivalent of 25. If we perform the AND operation between 12 and 25, we can see that only this part has both the inputs to be ones. Henceforth, the resultant is 1 in the output. Okay. If we again convert the binary representation into the decimal value, that is going to serve as the input of this particular code. So, when we execute this code by giving the values as 12 and 25, we will be getting the output as 8. Bitwise OR operator, you can see a symbol called caret. The name of the symbol is caret, which is used as the bitwise OR operator, which compares each bit of its first operand to the corresponding bit of the second operand. If both bits are ones or both bits are zeros, then the corresponding result is going to be 0. Otherwise, it sets the corresponding result to be 1. This is the case with XOR operation, bitwise XOR operation. So, how it is performed? Let us see with an example. So, we will take again two 16-bit binary values, we will perform the bitwise XOR operation. So, the truth table of bitwise XOR operation, we can see that if both the inputs are zeros, then we get the output to be 0. Again if both ones both the inputs are ones, we again get the output to be zeros, or otherwise if the inputs are unlike inputs, we get the output to be 1. Okay. We will apply the same XOR operation with respect to the given inputs. So, here we will take the first two inputs. So, here it is 0 and 1. So, we get the output to be 1, 0 and 1 unlike inputs. So, 1, 0, 1 and 0 unlike inputs. So, 1. So, here we get the like inputs. So, output is 0. Here again for all the like inputs, we will be getting the output to be all zeros. So, this is the representation of bitwise XOR operation. Again on applying this process as a code, the same example we will take. The only difference is instead of AND, we will just replace it with the OR operation. So, here again the results will be we will take the binary representation of, we will see the bitwise XOR operation on applying through a program. So, here again we will take the same value input for A to be 12 and 25 for B. So, here instead of the AND operation, we will use the caret symbol for exclusive OR operation, and we will be working out with the binary representation of 12 and 25. So, here we can see that the first bit corresponding bits are zeros and ones, hence we get the output to be 1, and for the second bit representation both are 0. So, 0, and for the third bit representation it is 1 and 0. So, we get 1, then 1 and 1 we get 0, and then 0 and 1 we get 1, and all the other bits are 0. So, we will be getting the output to be zeros. So, if we convert that to the decimal value, we will be getting the value 21. So, this is how the XOR operator can be used with respect to a program, and the results can be obtained. Now, let us learn about bitwise complement or ones complement or NOT operator. So, we will be using the symbol tilde. The name of the symbol is it is tilde, and it is actually used for negating the bits. It means that in the binary representation, if the bit 1 exists, it will be replaced with bit 0, and if it is 0, it will be replaced with binary value 1. So, let us take an example of the binary representation, which is again a 16 bit representation. So, this if it is applied with the tilde symbol, it negates the complete bit stream by replacing 0 with 1, again 0 with 1, 0 with 1, and then 1 with 0. So, it goes on, all other bits are zeros, henceforth it is all replaced with all ones. So, if we take how to represent the tilde symbol operation, it is just by negating using the tilde, the value 0 will be converting its one to its ones complement, and it makes all 1 representations. And let us look at the bitwise shift operators. So, the bitwise shift operators, as we have already seen, this will be shifting the position of the bits towards left or towards right, depending on the type of operator we use. So, how we will be able to apply the shift operator? Just with the n bits representation, use a left shift operator, and then how many number of locations we want to shift, that can be represented as the right hand side operand. Similarly, for the right shift operator also, we can represent what sort of bit stream we want to right shift and how many bits we want to move towards right, that can be mentioned with the right hand side assign operator. For both leftward shift, the vacated right bits are set to 0. For rightward shift, the vacated left bits are filled based on the type of the first operand after conversion. If the data type is going to be unsigned, they are by default set to 0, otherwise they are all filled with the copies of the signed bit. So, let us see how it actually being operated as an expression. So, we will be able to give the left shift operation without overflow using expression 1 and then use the left shift operator and expression 2. So, this is actually equal to multiplying by 2 power expression 2. Similarly, the right shift operation is equivalent to division by 2 power expression 2. The result of the shift operation is undefined if the second operand is negative or if the right operand is greater than or equal to the width in n bits of the promoted left operand. So, these are the points to be taken care with respect to bitwise shift operators. So, let us take an example. I want to do the shift operation with respect to a value 2030. So, we will have to first represent the binary representation of 2030, which is actually which is the one which is shown here, and we will now apply the left shift thrice. So, how do we do? We will have to represent the variable name and then apply the left shift operation 3 times. So, we are supposed to move the bit streams towards left 3 times. Okay. So, how do we do? So, this is the actual representation, bit representation. When I shift left once, so this value, the value 0 will now come to this position and then all other bits will be moved towards left. One additional 0 will be added to the first left shift operation. For the second left shift operation, already we have a 0. So, it is again still moved towards left one more step. So, on moving thrice, we will be able to get the 3 zeros added with the actual data. The actual data starts from this point and now new 3 zeros are being added because we are shifting it towards left. And similarly, when we try to shift it towards right, at the right side the data will be pushed and the zeros will be added towards the left. So, this is where actually the data stream starts. These 3 zeros are added towards the left. The actual data will be pushed towards the right or shifted towards the right. So, when we apply the left shift and right shift operator in a code, how do we do it? Okay. So, we are just declaring a variable of integer type and its values 2 and 2, and we use a loop to do the right shift operation and left shift operation. I do the right shift operation first. The loop will be executed for 3 times starting from 0 to 2. So, we start the loop from 0. So, when the I value is 0, we do the first right shift operation. On shifting, when the value is 0, we do not do the right shift. So, the value is actually 2 1 2. When it becomes 2, that is when the loop is executed for the next time, we do one left shift operation, because for the first time we do the right shift operation with respect to the value I. So, this will be represented as num right shift 0 for the first time. So, we are not doing any right shift. So, the value remains the same, and for the next time we do num right shift once. So, when I right shift 2 1 2 once, this becomes 106, division by 2, and again we will be rotating or right shifting twice. So, on right shifting twice, the value still becomes 53. The same way, the same loop is carried out even for the left shift operation. So, the left shift operation again for the first time it is 0. So, it is again 2 1 2. For the next time left shift, it becomes left shift once. So, it is multiplied actually, then it becomes 4 to 4, then we get 848 for the next left shift. So, this is how we can execute the code on applying the bitwise shift operators in the code. So, we have now learnt the application of bitwise operators in C program. Now, we will focus on learning more on the special operators that C compiler uses. The special operators are comma operator, size of operator and pointer operators. So, pointer operator we have two symbols ampersand and asterisk. So, let us learn one by one. The comma operator actually contains two operands of any type separated by a comma. So, where we actually will be using this comma operator is on various situations. At the time of calling a function, we will be separating the arguments using the comma operator and entering or repeating an iteration loop. So, this is again one more situation we will be applying the comma operator. Then we will be using for testing a condition and other situations where a side effect is required, but the result of the expression is not immediately needed, we will be using the comma operator again. We will see the examples of the application of comma operator one by one. Before that, the comma operator discards its first argument. It is generally only useful where the first operand has desirable side effects. So, the first example what we can see in the table is the situation where the comma operator is used in iteration. So, we can see here that there is a loop I equal to 0. This is the first statement, initialization, and the second statement is the condition checking statement, but the third statement we can see it is of two statements separated by the comma operator. It means that simultaneously these two operators, these two statements can be executed separating by comma, provided the first operand will be I plus I and then it executes the function. The second statement or the second example is the one in which the comma operator is used in the if statement. So, an if statement in which the function is called, variable I is incremented and variable I is tested against a value. There are two steps here. If the function is called, then the value of I should be incremented and then it should be evaluated using a condition. So, the first two expressions within the comma expression are evaluated before the expression I greater than 1. So, regardless of the results of the first two expressions, the third is evaluated and its result determines whether if statement is processed or not. So, this is one of the application of the comma operator, and the third category is wherein we can make use of the comma operator to separate the arguments in a function call. In a function call statement, we will be using list of arguments. So, this is argument 1 and this is argument 2. So, if at all if both the arguments are to be separated, we will again go for using the comma operator to separate the arguments at the time of calling the function. And the last one is at the time of variable declaration. The variable declaration, we can use the same statement for declaring more than one variable, and also we can assign values to the variables. At that time, the variable initialization can be separated by comma operator. If it is separated by comma operator, it is it means that the process will be the same, but the execution or the variable usage will be different. So, in this case, I num equal to 3, this is one statement, I num equal to 7, this is one more initialization statement, and I num 3 equal to 2, this is again one more initialization statement. But all these three variables are of the same data type int. If this is the case, then these three initialization statement can be combined. At the same time, if it can be separated using the comma operator. So, that is the use of the comma operator, which is a special operator in C. And we have one more special operator called size of operator. So, this operator will help us find the size of a data type in case if the data type or if the variable is supplied as input to the size of operator, it is able to determine the size, how many bytes that the particular variable declaration consumes in memory. Say for instance, we will take one integer type variable, we will take one character type variable, also the float type variable. The size of IVAR, it is displayed to be 3, and the size of character type variable it is displayed to be 1, and the size of floating point variable is given to be 4. If we want to find the size, we can make use of the size of operator. The third type of special operator is pointer operator. The concept of pointers is very interesting in C language, which will allow us to access the address locations with the help of a variable. The pointer variables are the one which can store or contain the address of another variable. Okay. Supposing if I am declaring a variable int a equal to 5, we have already learnt that in the memory location there will be a location assigned for the variable a, and let us assume that the address of the variable is 5000. Okay. Supposing if I want to know what is the address associated with that particular variable, I can make use of the pointers. So, how to declare a variable to be a pointer is with this syntax: int asterisk pointer variable. So, asterisk is the operator used for declaring a variable to be a pointer variable which can hold the address of another variable. So, what I need to do? I need to declare a pointer type variable. So, using asterisk s, I declare a pointer type variable. So, I want to assign the address of the variable a to the pointer s. So, what I do? S equal to ampersand a. So, now ampersand operator refers to the address of the location where the variable a is stored. So, here we use two symbols, one is asterisk and one is ampersand. Asterisk is to declare a variable to be a pointer variable, and ampersand is used to assign the address to the pointer variable. So, this is how the pointer operators are operated in C. So, multiple pointers require multiple asterisks, in the sense that, so I can go with declaring one pointer variable, the other pointer variable also. So, as we have discussed, int y equal to 5, int asterisk y pointer, I am declaring a pointer type variable, then y pointer equal to ampersand y. By doing so, I am assigning the address of that variable to y pointer. So, from the figure you can find out that y pointer is the pointer variable which points to the variable y. So, y has the address, this address, which is actually the value stored in y pointer. So, when I want to know what is the address of y, it is enough if I know the y pointer, I can locate the address where actually y is stored. So, coming to the summarization point, in this module we have learnt about the bitwise operator, out of which we have seen the examples for bitwise AND operator, exclusive OR, and then NOT operator. Also we have learnt about the ones complement operator and shift, left shift and right shift operators, and We have also learnt about the special operators, on which we have seen illustrated the examples with respect to comma operator, size of operator and pointer operators. So, these three operators are considered to be special operators with respect to the C language. I hope we have learnt and understood the bitwise and special operators in this module very well. Thank you so much.